Me myself Sumaya T, student of 4th semester BSc Mathematics from E-Content Development Center of Majlis Arts and Science College, Puramannur. Today we are going to discuss about binomial distributions. The distributions obtained from a theoretical listing of outcomes which can be described by a mathematical model is called expecting probability distributions. There are many types of distributions, namely Bernoulli distributions, Poisson distributions, binomial distribution, etc. And today in this section we are going to discuss about binomial distribution. Now we are going to discuss about binomial distributions. Let x be a random variable with probability mass function given by f of x equals to ncx p raised to x into q raised to n minus x, where x equals to 1, 2, 3, etc. and 0 less than or equals to p less than or equals to 1 and p plus q equals to 1, or f of x equals to 0 other ways. Then x is said to follow binomial distributions with parameters n and p. It can be written as x givens and p, where x is the number of successes. Mean of binomial distribution equals to E of x equals to np, and the variance of binomial distribution equals to V of x equals to npq. Next we are going to discuss how we obtain the mean of binomial distribution. Mean of binomial distribution equals to summation of x into f of x. We know the value of f of x. F of x equals to ncx p raised to x into q raised to n minus x. Now we are substituting the value of f of x into this equation. Mean equals to summation of x into ncx p raised to x into q raised to n minus x equals to summation of x into n factorial divided by x factorial into n minus x factorial into p raised to x into q raised to n minus x equals to summation of x n factorial divided by x into x minus 1 factorial into n minus x factorial into p raised to x into q raised to n minus x equals to np into summation n minus 1 factorial divided by x minus 1 factorial into n minus x factorial into p raised to x into q raised to n minus x equals to np into summation n minus 1 c x minus 1 p raised to x into q raised to n minus x equals to np into p plus q raised to n minus 1. And we know that p plus q equals to 1, satisfying the binomial distributions. So 1 raised to any other number equals to 1 itself. So p plus q raised to n minus 1 equals to 1 itself. So the mean of binomial distribution equals to np. Now next we can discuss a question related to binomial distributions. And here is the question. The mean and variance of a binomial distribution are 2.5 and 1.875 respectively. Obtain the binomial probability. In this question we want to obtain the binomial probability by using the parameters such as mean equals to 2.5 and variance equals to 1.875. Now we can solve this question. Given mean equals to np equals to 2.5 and variance equals to npq equals to 1.875. We want to obtain the values of n, p and q. So the value of mean and variance is given, then q equals to npq divided by np. We know the value of npq equals to 1.875 and the value of mean np equals to 2.5. So 1.875 divided by 2.5 equals to 0.75. Therefore, and we know that p plus q equals to 1, satisfying the equation of binomial distribution. So p equals to 1 minus q and the value of q equals to 0.75. So p equals to 0.25. Since np equals to 2.5, the value of p is obtained that p equals to 0.25. Therefore, n equals to 2.5 divided by 0.25 equals to 10. Now we also obtain the value of P, Q and N. Therefore, Q equals to 0.75, P equals to 0.25 and finally N equals to 10. Now we are going to obtain the binomial probability distribution. The binomial probability distribution is f of x equals to ncx p raised to x into q raised to n minus x, where x equals to 1, 2, 3, etc. n. And now we had obtained the value of n, p and q such that n equals to 10, p equals to 0.25 and q equals to 0.75. Now we are substituting the values of n, p and q in this equation. So f of x becomes 10cx into 0.25 raised to x into 0.75 raised to 10 minus x, where x equals to 1, 2, 3, etc. 10. Hope you all understood my section. Thank you.